Rachel Mullins, President and CEO of the Putnam Museum and Science Center. We're a museum of history, culture, and science whose mission is to ignite human potential and inspire our diverse community to learn about and care for our world and all its people. We have some new galleries here at the Putnam that support that mission by exploring the natural forces that have shaped our world and how that impacts our human experience in the past, present, and in the future.
Hey everybody, welcome back. Miss Lakin here at the Putnam Museum and Science Center. I'm excited to be with you here today. We are in the Putnam Space Gallery. Today's topic is all about space. Miss Chris will show you some cool artifacts we have here at the museum. I'll walk you through your activities in your activity kit, and we're going to do a little peek at one of the interactives here in the gallery. So this is the Putnam's Magic Planet. It's a 3D virtual reality sphere, and it's really cool because we can explore our different planets we have in our solar system. So right now, this is Mercury. I'll walk you through and show you some of the different planets. This one's Venus. Oh yeah, this one's really cool. Here we go. We're gonna go to planet Earth, that third planet from the sun. We have Mars, Jupiter. We're getting to our big planets. Saturn, Uranus, and last one, Neptune. So, and we'll actually, I'll show you the sun too, because all of our planets in our solar system orbit and circle around the sun. And then we'll go back to planet Earth. This interactive is really neat too because you can explore and read more about what NASA has developed over time. Some of the things that they have done have made space travel easier and safer, so that's really cool. So with that being said, let's get started.
Hi everyone, my name's Chris Chandler. I'm the Curator of Natural Science here at the Putnam, and today we're going to talk about visitors from outer space, and it's not the ET kind. We're going to talk about rocks that come from outer space. One of the things that's fun about being a curator is you get to deal with all sorts of different types of objects. Everything from rocks to fossils to pinned insects and pressed plants. But one of my favorite things are actually meteorites. In Iowa, we actually have a very large impact structure. We don't have any meteorites because it blew up before it hit the ground, and it literally disintegrated into, I guess, dust is what it would end up being, if that. It pretty much vaporized on impact. This happened about 74 million years ago. That's during the age of the dinosaurs. That's the late Cretaceous. And it happened near Manson, Iowa. Around Manson, they always thought something weird was going on with the geology there. Around Manson, they actually had soft water. They also dug wells, and they would find what looks like breccia, which looks like rocks where you've basically thrown them down and broken them into pieces, and they're all jumbled together and they have sharp edges. That's not common for around here. And finally, when they were drilling cores, they actually drilled cores down in to see what's going on. They came up with that they found shock quartz, and quartz actually will change if it's impacted really, really hard. You actually can change the structure of quartz. And they found shock quartz, and they're like, okay, that means something really weird has happened here. And at first, they thought maybe it was a volcano, that maybe it was a volcano that was under the ground. Well, when they started looking closer, they realized it's an impact. It's a huge impact crater. So like I said, the problem, of course, is that it's covered by all the sediment that's from glaciers that have come down. So it's covered by like 100 to 300 feet of glacial drift, which means it's really hard to study it. But what they figured out now is that it's like 23 miles across. The object was probably about a mile in diameter. It may have weighed up to 10 billion tons, and it probably hit the Earth at a speed of about 45,000 miles per hour. Obviously, that's why it basically vaporized when it hit. So some of the things, we always talk about what happens when one of these hits. Probably set fire to everything within 130 miles of the impact, which is pretty much all of Iowa. Would have been toast. May have, because it hit at the edge. This is where this is actually at the edge of what would have been a Cretaceous seaway, a very shallow seaway. Could have easily created a huge tsunami, giant tidal wave. Also would have spewed a bunch of carbon dioxide and water vapor into the air. Not good either. The shock wave that it produced probably would have toppled trees up to 300 miles away. So we're talking toppling trees from Chicago to Minneapolis to St. Louis. And the real sad part is within about 650 miles in radius around it, probably killed every animal on that space between. So that's like from Detroit to Denver. Pretty much all the dinosaurs would have died. Dinosaurs have had it a hard time, right? I mean, you gotta feel sorry for them. One of the things that's one of those things where it's like, if you think about what would have happened if they hadn't had the asteroid impact. Because at one point they thought that this one might have been the dinosaur killer. But they realized that it actually was too early. It's about 9 million years too early. Dinosaurs had 9 million years to come over and take the land over again in the area, because then about 9 million years later, down at the tip of the Yucatan Peninsula, another huge asteroid hit, and it probably was about 5 times the size of the Manson impact. And we all think those are really huge, and it is terrible because if you think about it, it killed about 50% of all animal life on the planet, actually possibly 50% of all life on the planet. But that's not the worst one, right? Before the age of the dinosaurs, at the end of the Permian, there was one that possibly was an asteroid hit also, and it killed up to 90% of all life on the planet. That's just crazy. The good news is that they only happen really, 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 really rarely.
And then we'll get started making our paper model. Okay, now that we have all of our supplies ready, we're ready to make the Earth, Moon, and Sun model. So I've done this ahead of time, so you can go ahead and do this. I've colored my paper plate to represent the sun, and I've cut out my template pieces. Go ahead and pause the video and go ahead and cut that out, or just follow along as I show you how to assemble it. Once you have everything cut out, go ahead and you're going to poke a hole through planet Earth, through the moon, on both sides of your strips of paper, and right in the middle of your sun. And now we're ready to assemble. So go ahead and take your moon, and you're going to take one of the little brads and go ahead and push that through the center of your moon, and we're going to attach it to our small strip of paper. So go ahead and push that through and fold down the other side of the brad. So your moon should be attached just like that. Now you're going to take your planet Earth, go ahead and push the next brad through, and you're going to attach that to the other end of that strip of paper. And don't close it quite yet. We're going to add this long piece right here on this side. And then go ahead and close that brad. And the last part to our model is attaching this long end to the back of our sun. So go ahead, the last brad here, push it through the center, flip it over, and attach this long strip to this one. Okay, and here we have our sun, earth, and moon model. NASA's work has not only allowed us to explore our solar system, galaxy, and beyond, it has also had real impact on everyday lives. This array of planets we've created for our gallery shows some of the inventions NASA originally developed for the space program that regular people now use every day. Some of these innovative technologies include memory foam insoles, LEDs, the space blanket, water filtration technology, dichroic glass, scratch-resistant lenses and freeze-dried food, Speedo swimsuit material, and fiber optics. NASA has researched drag reduction for aircrafts for decades, so why not swimsuit material? In fact, dozens of swimsuit fabrics have been tested in NASA's Langley low-speed wind tunnel. Michael Phelps, American Olympic swimmer, wore a NASA-tested Speedo in the 2008 Beijing Olympics. Water produced as a byproduct of onboard fuel cells, or otherwise recycled, needs to be cleansed of bacteria before it can be consumed. To ensure the safety of onboard water supplies, NASA invented a device that killed bacteria by shooting the water full of negatively charged silver atoms, essentially an electronic water purification device. The technology was soon adapted for everyday use. Small, compact water filters are now found in households throughout the world. You may owe the bounce in your step to NASA. Memory foam has been around since the mid-1960s, when NASA developed it for airplane seats. From the Tempur-Pedic mattress to your shoes' insoles, memory foam is a NASA spin-off that just keeps giving. It even spun back to NASA. An obstacle course featuring a special 4-inch thick memory foam floor is being used to evaluate how well astronauts are adjusting to the return to gravity on Earth.